Hello everyone. Today we'll be talking about the Galileo's law of odd numbers. It's super important and it makes few calculations very quick. For better conceptual understanding, you'll be getting one checkpoint in this video and its answers can be verified at the end of this video. So let's begin. Here we can see the statement made by the Galileo. If an object is starting from rest and its acceleration is constant, then distances traveled by the object in the equal intervals of time are in the ratio of the odd numbers, namely 1:3:5:7:9 and so on. Getting it? Let's try to prove it. Suppose here is a building and a ball is released from the top of this building. So at t is equal to 0, u is 0, means the initial velocity of the ball is 0 and acceleration due to gravity is constant. Downward direction we are choosing as the positive and we will find the distance traveled by the ball in every second, means distance traveled in the first second, distance traveled in the second second, distance traveled in the third second and so on. So I am starting the calculation. We can use this formula. S is equal to u plus a by 2, 2n minus 1. I hope you remember the formula for the displacement in the nth second. And since here the motion is unidirectional, so the magnitude of the displacement is equal to the distance traveled. Now I am obtaining the distance traveled in the first second. Let us put up the data. U is 0, acceleration is g only, and here at the place of n we'll put 1 minus 1. What we get here? This is equal to 1g by 2. Okay. Now let us obtain the displacement in the second second. What we should put here? 0 plus g by 2, 2 into, at the place of n, now we should put here 2 minus 1. What we obtain here? It is equal to 3 times g by 2. Can you guess what will be the distance traveled in the third second? In the same manner, you can tell the distance traveled in the third second will be actually equal to 5g by 2. Let us compute it. 0 plus g by 2, 2 into, at the place of n, we will put here 3 minus 1. Okay. If you need the distance traveled in 4th second, 5th second, so on, you can do the computation and you can see the ratio here 1:3:5:7. Getting it? So I am writing that here distance traveled in the first second is to distance traveled in the second second is to distance traveled in the third second will be in the ratio of 1:3:5. Okay, odd numbers. It's important. I request you to note it down and then we'll go further. Okay. And here is another important observation by the Galileo. If an object starts from rest, its acceleration is uniform, then the total distance traveled by the object increases as the square of the time taken. Okay, let's prove it here. Suppose we take the same example of the ball which is released from the top of a building. So we need to find the distance traveled in the time interval 0 to 1 second. Which formula we can use? We know that S is equal to ut plus half at square. Okay, so here I should put u is equal to 0, time is 1 plus half g into 1 square. Clear? You can write this as g by 2 multiplied with the 1 square. Now we need the total distance traveled in the time interval 0 to 2 second. Then it will be equal to 0 into 2 plus half g into 2 square, which will be equal to g by 2 multiplied with 2 square. Do you agree? Total distance traveled in the time interval 0 to 3 second. That will be equal to 0 into 3 plus half g, okay, into 3 square. So it will be actually g by 2 multiplied with 3 square, and so on. We can do further computations. So here we can deduce the important ratio. You can note down this one also, and then we'll be taking up numerous good examples to understand these things. Okay. Here is the first important question. A car moves 300 meter in the time interval 5 second to 20 second, and then we need to find the distance traveled by the car in the time interval 10 second to 20 second. Getting it? If you wish, you may pause the video here and give it a try yourself. Simple and easy question. Then I'll be solving it here on the board. I hope you are done with your calculations. Let's see the solution here. Since it is starting from rest, its acceleration is constant, we can use the Galileo's law of odd numbers if we find the distance traveled in the equal intervals of time. So what I'll do, we'll consider here equal intervals of time. Let's say this is t is equal to 0 second, this is t is equal to 5 second, this is t is equal to 10 second, t is equal to 15 second, and then at last we have here t is equal to 20 second. These are equal intervals of time, 5 second, 5 second, 5 second, 5 second each. Okay. Question is telling us that in this time interval t is equal to 5 second to t is equal to 20 second, the car is traveling a distance of 300 meter, and we need to find this distance traveled from t is equal to 10 second to t is equal to 20 second. This is our target. Clear? Since it is satisfying the Galileo's law of odd numbers, a is constant, u is equal to 0, and we are obtaining the distances traveled in the equal intervals of time. So the distances will be in the ratio of the odd numbers. It means if we consider this as x, then this should be 3x, this should be 5x, and this should be 7x. Do you get it? I repeat it, equal intervals of time, then the distances traveled in these equal intervals of time will stand in the ratio of the odd numbers starting with unity. So 1 is to 3 is to 5 is to 7. Okay. Now the computation is pretty simple. Can you see 300 meter is equal to what? So I am writing it here. 300 meter is equal to 3x plus 5x plus 7x. So the 300 meter is actually equal to 8x plus 7x, which is 15x. So x comes out to be 20 meter. Now we need this distance. For computing this distance, 5x plus 7x should be our answer. So which is equal to 12x. Value of x we have already obtained. So this unknown distance will be 12 into 20 meter, which is equal to 240 meter. Simple and quick computation. I hope you understood the method. Using the Galileo's law, the calculation becomes quick. Okay. You even need not know about the data of the acceleration, and then you can obtain your answer. So it's nice method. Done? Note it down. Then we'll be taking up the next great question. Here is the next brilliant question. The acceleration of the car is constant and we need to find the distance traveled in the fifth half second. If you wish, you can try to solve it using the equations of motion, or faster resolution of the problem, you can use the Galileo's law of odd numbers. Give it a try, then I'll be simplifying it. I hope you are done with your calculations. So let's see it here. Suppose this moment of time we consider as t is equal to 0 second. I am taking the equal intervals of time in order to apply the Galileo's law of odd numbers, because here acceleration is constant, u is already given as 0. This is t is equal to 1 into half second. This is t is equal to 2 into half second. T is equal to 3 into half second. 4 into half second, and here we have t is equal to 5 into half second. Equal intervals of time are available. Acceleration is constant. So according to the Galileo's law, the distances traveled will be in the ratio of the odd numbers. So if this distance is x, this should be 3x, this should be 5x. Speak up, what is this? 7x, correct, and this should be 9x. Do you agree? What you need to obtain? Distance traveled in the fifth half second. See the diagram. The fourth half second gets over here. So this is the fifth half second. It means this 9x is our answer. Now the computation can be done very easily. First of all, I am computing this x. X is equal to ut plus half at square. U is 0. Acceleration is 2 and time is half second. Check this computation. This will give us 1 by 4 meter. Done. Now the answer is pretty simple. The required answer will be equal to 9 into 1 by 4 meter, which is equal to 2.25 meter. See the quick and easy solution using the law of odd numbers. You can do this question in another way. What you do? Use this equation for this total interval of time. Then you will get this much distance. Then again use the same equation for this much interval of time. You will get this distance. And then you can get the difference of these distances. You'll obtain your answer. That will be a bit time consuming. This method is smarter one. Okay, note it down. Then I'll bring the next question. Here you can see the next important question. You can try it with the equations of the motion, or you can use the Galileo's law of odd numbers. Choice is yours. Give it a try. I hope you are done with your calculations. This question can be solved using the equations of motion as well as using the Galileo's law of odd numbers. I'll show you why Galileo's law of odd number is a better choice. I'll be initially solving the question using the equations of motion for the constant acceleration. That will consume more time. And the same question when I'll be solving using the Galileo's law of odd numbers, it will take less amount of time. Okay. So Galileo's law of odd numbers is an additional tool to make calculations easy. Although without that law, we can easily solve the questions like this. Pay attention here. We have the inclined plane. This length is given as 10 meter in the question. And this height is given as 5 meter. Using this, we can compute this angle theta. We know that sine theta will be equal to 5 by 10, which is equal to half. So theta comes out to be 30 degree. Okay. Now acceleration due to gravity is in this direction. Its data is given as 10 meter per second square. For doing the calculations, we need the acceleration along the incline. Okay. For that, we'll require this component of the acceleration due to gravity. This can easily be obtained. If this angle is 90 degree, this angle will be 60 degree. So here this angle will be 60 degree. So the component of g in this direction will be g cos 60 degree. G cos 60 degree, when you simplify, will give us 5 meter per second square. Okay. Now suppose this distance is x1, this distance is x2, and this distance is x3. Okay, the time taken in traveling this distance x1 is, let's say, t. The time taken in traveling this distance x2 is also t. I am taking the equal intervals of time as the question said. Time taken to travel this distance x3 is also t. Do you agree? Now I am using the equation of motion for this total time interval, t plus t plus t. So pay attention here. Shall I write x1 plus x2 plus x3 is equal to 0 into 3t plus half into 5, this acceleration, 3t whole square. Do you agree? Simple thing, and this is actually equal to 10 meter. Okay, call it equation number 1. Making the second equation, if we check for this distance x1 plus x2 and try to make an equation like this, then x1 plus x2 will be actually equal to 0 into 2t plus half into 5 into 2t whole square. We call it equation number 2. Done. And for this distance x1, I am again using the second equation of motion. X1 will be equal to 0 into t plus half 5 into t whole square. Call it equation number 3. Now, can you solve all these 3 equations? Equation 1, 2 and 3. I have the shortage of the space here, so I recommend you to do the calculations. When you solve equation 1, 2 and 3, you will get the value of t, which is equal to 2 by 3 second. Okay. Now, if you know that t, you can easily calculate x1, x2, x3. That computation I am doing here. x1 is equal to half into 5 into 2 by 3 whole square. So x1 will come out to be 5 by 2 into 4 by 9 meter. Getting it? Which is equal to 10 by 9 meter. This is the first data. Now, if you put here the value of x1 and you put here the value of t, then you will get the x2. Again, the issue of the space is there, so you can do the calculations. I am directly writing the answer for x2. x2 will come out to be 10 by 3 meter. You note it down. I need to clean the board, and then I'll be solving this question very quickly using the Galileo's law of odd numbers. Since the object is starting from rest, its acceleration is constant, and we are finding the distances traveled in the equal intervals of time. So we can easily use the Galileo's law of odd numbers. Using Galileo's law, we should write x1 is to x2 is to x3 is equal to 1 is to 3 is to 5. Do you agree? And another piece of information, looking at the diagram in the question, we should write x1 plus x2 plus x3 should be equal to 10 meter. Getting it? Now the computation is pretty simple. You obtain x1 in this manner. Take this data 1, divide by 1 plus 3 plus 5 and multiply it with 10 meter. I hope you know how to solve such ratios when you know this data. Doing this computation, you will get 10 by 9 meter. Is it okay? Now I am computing the x2. For computation of x2, take this number 3 here in numerator, then sum up all these numbers 1 plus 3 plus 5 and multiply it with 10 meter. Okay. Now your answer comes 3 into 10 by 9 meter. You can check it. This is 10, this is 9 and here was 3. And the last computation for x3 is equal to 5 divided by 1 plus 3 plus 5 multiplied with 10 meter, and this comes out to be 5 into 10 by 9 meter. For simplicity, you can write this as 10 by 3 meter and this as 50 by 9 meter. You can check, this ratio is 1:3:5. Getting it? And now match your answer with your previous calculation. Check your notebook. In the previous calculation also, you got the same answers. See the advantage of this method. While using this method, we need not know about the magnitude of the acceleration. We need not make too many equations. So this method is brilliant one. Okay, note it down. Then we'll be taking up the next question. Here is another simple and nice question for you. If you wish, you may give it a try by pausing the video here. You should try it solving with the equations of the motion, as well as you should try it with the Galileo's law of odd numbers. You'll enjoy. I hope you are done with your calculations. So first I am solving it using the equations of motion. We know that the distance traveled for the time interval 0 to 3 second is equal to the distance traveled in the last second. It is given in the question. Let us assume that the last second is the nth second. Getting it? Here we should use which equation then? S nth, which is equal to u plus a by 2, 2n minus 1, and here we should use ut plus half at square. Do you agree? This equation is used for total time interval. This equation is used for the nth second. We know that u is given as 0. Body is starting from rest. So this is 0, this is 0. Then this a by 2 will get cancelled out in LHS and RHS. So I am cancelling this a by 2. Now the moment of time here you will put as 3. Square is equal to 2n minus 1. Compute it. N comes out to be 5. It means the object will take 5 seconds to hit the ground. Clear? Now I am doing the same calculation using the Galileo's law of odd numbers. Suppose this is the building, t is equal to 0, u is equal to 0. Object is released from here. Done. And acceleration due to gravity is constant. It is satisfying all the conditions of the Galileo's law of odd numbers. U is equal to 0 starting from rest. Acceleration is constant. And then I'll be taking up equal intervals of time. Let's say this is t is equal to 0 second. This is t is equal to 1 second. T is equal to 2 second. T is equal to 3 second. T is equal to 4 second. And here is t is equal to 5 second. Equal intervals of time are taken. Then the distances traveled will be in the ratio of the odd numbers. It means if I take this distance as x, this should be 3x, this should be 5x, this should be 7x, this should be 9x. Okay. Now according to the question, the distance traveled in the initial 3 seconds means this distance. I am doing the calculation here according to question. X plus 3x plus 5x. Okay. This distance should be equal to what? The distance traveled in the last second. This distance actually comes out to be 9x. Where you are traveling the 9x distance? Here. So the last second should be equal to t is equal to 5 seconds. I hope you understood the question. the distance traveled in the initial 3 seconds is equal to the distance traveled in the last second. So just by looking at the diagram, you can answer that t will be equal to 5 seconds. I hope you got it. It's brilliant method. Okay. Now here is the last question of this video. Give it your best shot using the Galileo's law of odd numbers. Now I am solving this last question of the video using the Galileo's law of odd numbers. Looking at this diagram, let's have a simple representation of the things here. Suppose this is the first drop. Okay. This is the second drop. This is the third drop. And here is the fourth drop. Since these drops are starting from rest, acceleration due to gravity is constant, and we are talking of the distances traveled in the equal interval of time. So we can easily use the Galileo's law of odd numbers. So if this is x, this should be equal to 3x, and this must be equal to 5x. Do you agree? According to the diagram of the question, we know that x plus 3x plus 5x is equal to 18 meter. This computation gives us 9x is equal to 18 meter. So x comes out to be 2 meter. Now we need the position of the second drop and the third drop from the ground. So from the ground, the second drop is at a height of 5x, and 5x will be actually equal to 10 meter. The third drop is at a height of 8x from the ground. So the third drop here is having the data 16 meter for the height, and the fourth drop is at a height of 18 meter. It's already given in the question. I hope you enjoyed the video. Happy learning. Stay awesome.